Hello everyone, I'm Zhan, and I'm going to present our paper titled with Contract Theory Based Blockchain Reward and Penalty Mechanism for Construction Tendering among Multiple Stakeholders. And here is our asset list and their associated affiliations. And firstly, I'm going to introduce the background of our work. The background of our work is based on tendering. As we all know, the tendering is awarding the contract to the eligible contractor, which offers the best bidder proposal. And here is the evolution trajectory of the tendering. The first stage of tendering is the traditional bidding process. This process, the implementation method of this stage is paperwork oriented and rely on a third trust party. And some issues for this work is data privacy, fraud, multi-party exclusion, and data manipulation. And for the second stage is the electronic tendering. The implementation method of this method is an online system and also rely on a third trust party. The enhancement of this method is the administration and the data storage cost will be lower than the traditional bidding process, but the issues remains. And for the third one is blockchain-based tendering. This method is based on blockchain, and the enhancement is get rid of the reliance of the third trust party. But there are also some issues exist, and the issues can be observed from the workflow of blockchain-based tendering, especially the 6 steps of the workflow. For example, we can observe 2. The first one is the decisions can only be made based on public information uploaded by suppliers, and the second one is the initiative is in suppliers' hands. For the first one, it will result in the issue of private, like this one, is the private information can also impact GC's utility. GC is the general contractor. And for the second one is the suppliers may include and then take the project at a low cost. To be more specific, like the private information can be the material delivery time of the suppliers, as we can say this too. The first one is delivery to be controlled in a precise to be controlled precisely, and the below one is the arrow is much larger than the above one, so the utility for the GC will be higher in comparison with the below one. The reason is the smaller the arrow in the delivery time and enables the higher profit for the general contractor. And for the second one is that the CLUD might extend the deadline of material delivery and reduce the bid required to win. And then the money will transfer from the GC to the suppliers. In this way, from the first issue, we can get the motivation one is like this one, in how to enable the general contractor to make the final decision based on suppliers private and both public information. And from the issue 2, we can obtain the second motivation is how to enable GC to possess the initiative during the tendering. Based on the motivation and the workflow of the blockchain-based tendering, we try to integrate contract theory into blockchain-based tendering. And how to integrate the contract theory is like this one. And the modified workflow of the blockchain-based tendering is like this one. We are including 8 steps. The first one is initiate pre-qualification and then to the blockchain, and the suppliers will upload their fields, and the blockchain platform will record the pre-qualification and based on some matrix to screen suppliers. And then for the 6th step is that the general contractor will formulate the contract bundles and issue the contracts on the block and stored on the blockchain platform. and then the suppliers will select the contracts, and the blockchain platform will, as per the pre-coded contract theory, smart contract to identify the winner of this from all of the suppliers, and then notify the general contractor and the suppliers. And here is the mathematic models of the contract theory, and this part is about the suppliers utility function. It's like this one. There are two key parameters. The first one, theta I, means the profitability of suppliers. It will have two values. One is high and another is low for clarity. And here is Ti is the optimization variable. This is promised delivery capability of suppliers. And for the detailed means of the parameter is like this one. The R bar means the reward from GC. And this parameter is the mean value of all suppliers' bid price. And alpha is the coefficient of delivery cost, and T bar is the initial delivery capability of suppliers. And P delta K is the penalty for material out of delivery, and this parameter is only related to the significance of material delta K. And tau is the probability of out of delivery, and delta R bar means the revenue of blockchain platform, and C is the blockchain's cost. And here is the mathematical model of contract theory for the GC's utility, and they're also including the TI. And for the parameters, the alpha prime is the GC's revenue coefficient, and D is the GC's initial revenue, and epsilon TI means the GC's additional revenue. And from this parameter is varying as per the delivery capability of different suppliers, and the beta is will vary as per the material. If there is enough material in the market, the parameter will in the range of 0 to 1, and otherwise, if the material is shortage, this parameter will in the range of 1 to 10. And alpha is the penalty for material out of delivery, and this parameter and this alpha is charged from the supplier, and the rho is the utility of supplier. And here is the problem formulation and the solution of the problem. And the first part is reflect the utility of supplier, and this one is integrating the competition of suppliers into the original function. And here lambda is the possibility of suppliers type. It's including two types. One is high and another is low. And X is the supplier's winning possibility. And phi and rho indicate the last two terms in the original function. And here is the optimization problem. The first one is the incentive rationality constraints, and this constraints can ensure that the utility of suppliers is greater than 0. And the second one is the incentive compatibility constraints, and these constraints can ensure that the suppliers can only select the contract bundles tailored for themselves. Otherwise, their utility will be decreased if they select the contract bundle that are not designed for them. And the third one is the bidding constraints. This constraint is to make sure that all suppliers' winning possibility sum up after summing up is lower than 1. And the final one is the contracts constraints, and this constraint is to enforce that the suppliers to deliver the material in the range of 0 to TK miles. And utilize the optimization methods, we can obtain the results like this one. For the detailed derivation procedures can be found in our paper. And this part is to introduce the experiment. And for this page, is varying contract theory parameters, and we can obtain two figures. One is figure 2 and figure 1 and figure 2, and the two conclusions can be drawn. The first one is drawn from figure 1. Figure 1 depicts the utility of GC increase where the edge type supplier increase. Since the GC will design the contract tailored for the edge type. The edge type means the material will deliver the capability of material delivery is higher, and then in this way the GC's utility will be higher. And for the figure 2, depicts that the utility of GC increase along with the delta K. The delta K is like this one, this curve. And the reason is that a strict delivery deadline requirement, the importance of the material delta K to be higher, and a strict delivery deadline will be posted to the suppliers, and then the GC can extract more profit and also reduce the risk. And the second experiment is to compare our process method with some benchmarks, and there are 4 benchmarks. The first one is the multilateral contract theory in complete information scenario. And this one is assume that all of the information, all of the private information of suppliers can be obtained by the general contract, and the second one is bilateral contract in incomplete information scenario. The difference between this one and our process method is this one is bilateral. The bilateral will not include the competition among the suppliers. However, our proposed one will include the competition among the suppliers. The third one is multilateral contract without blockchain, and our method is included the blockchain in incomplete information scenario. And for the final one is the traditional tendering scheme in incomplete information scenario. This one is without contract theory and also without the blockchain. And there are 3 conclusions can be drawn. The first one is our program method can always achieve the highest utility for GC when disregarding the complete contract. Since the contract is the ideal solution, it can be like this one. The right circle one is, since this can be deemed as the upper bound of the comparison methods. And the second conclusion is that our proposed multilateral contract theory achieves higher utility for GC than the bilateral one because of competition, just as we mentioned before. This blue triangle is the bilateral contract, and this gray rectangle is our proposed method. And the final conclusion is that our proposed method can improve the utility of GC by approximately 20.7% in comparison with no contract. No contract is like this one, the 5th bar, and in comparison to the first bar, the fourth bar is opposite one, and the first bar is the no contract, without contract and also without blockchain. And that's all. Thank you, and also thanks for the foundation of our work like this one.